So for those of you just joining, first, congratulations to all of you for kicking butt on the exam. I knew you guys could do it, never had a doubt. And you guys need to believe in yourself just like 5% more because you guys are really smart and you're hardworking. Second, since you have to do the ACS organic chemistry exam, it's a standardized test that's given across the country by the American Chemical Society. Due to that, it is a very difficult test, but usually it's curved. Usually, I'll throw that in there. But I can give you strategies because there are some really good strategies when working through the ACS exam. Like one of the better things is that you can usually eliminate some of the answers like right off the bat because some of them are just not going to make any sense. So if you have any practical understanding of the problem, you can usually eliminate 2 of the answers. So then that'll give you a 50-50, if you come down to it and you're kind of just stuck. So a second thing I would say is watch your time. You probably want to make sure that you're spending no more than 1.5 minutes on a problem. That way that gives you time at the end to go back. So if you spend 1.5 minutes on your problems, you're going to have about 10 to 15 minutes left to go back. So just do your best to watch your time, and then we'll go through and start talking about these. So let me just share my screen. Any questions before I get started with these review problems? All right, I will take that as a no. So if you get stuck on a question, yeah, move forward, come back later. So if you get stuck, just come back to it. All right. What is the correct IUPAC name for this compound? So I will let you go ahead and do that. Try to figure out what the correct name is of this IUPAC compound is. Let me know when you guys come up with an answer and we'll walk through this one. Or just throw it in the chat. Unmute yourself. Pretty soon, next year when you guys take Organic 2, maybe you guys won't need to meet. You guys are going to be ahead of the game. Okay, I see an A. Okay, and I got C. Okay, so right off the bat, are there any of these answers that you can just simply throw off of the, are there any answers that you can say, this is completely wrong?
B, because you can't have tert-butyl and IUPAC naming.
Yeah, you can't have IUPAC. Is there another one that you can throw out? Or is that it?
Yeah, D2.
Yep, because both B and D have tert-butyl and isopropyl. So remember, if it's an IUPAC name, you cannot use that. Okay, so then how do you solve this? Looking at A and C, what do you notice about A and C now? What's the main difference?
The location of the methyl.
Nope, even simpler than that.
Oh, the longest carbon chain?
The longest carbon chain, right? So if I start here and go 1, 2, 3, 4, 5, 6, 7, 8, I can find an octane right off the bat. So this is how you can do this real quick, is you can try and see what's the longest chain. So how easy then is that problem thinking back now? you eliminate two of them, right? And usually this is something that I've seen before with these IUPAC name questions, is that they'll typically have like isopropyl or tertbutyl snuck in there. And then you can just say, oh, well, I know that those aren't IUPAC names, so I can just throw them out. All right. Let's go next one. Question 2, what is the correct IUPAC name for this compound? Correct UPAC name for this compound. Go ahead and throw your answer in the chat when you get it. Okay, so it looks like you guys, a couple of you got D. So what is your biggest functional group in this molecule? The OH, alcohol, right? So your compound needs to end with an alcohol. Sometimes they may give you different functional groups and they may confuse you, but we know that it's going to be an alcohol. So then we just count the chain 1, 2, 3, 4, 5, 6, 7. So we have 7, so it should be HEP. So we can eliminate A, we can eliminate B. Now, since alcohol is my biggest functional group, does it go with the lowest number or the highest number?
The lowest?
Yes, so that's why it's going to be D. Because if you start this side and go 1, 2, 3, 4, 5, right? If I went the other way, 1, 2, 3, 4, 5, 6. So then my alcohol. You always want to put your largest functional group on the smallest number. Does that make sense? Okay, let's go ahead and go down to our next one. Question 3, which is the structure of Z35-dimethyl-3-nonene? So go ahead and think about that. As soon as you get an answer, go ahead and throw it into the chat and we will talk through which one this is. Okay, we got D. Okay, looks like you guys got D. So are there any answers that you can eliminate right off the bat?
A and C.
Well, first, why can you eliminate A?
Because the methyls aren't on carbons 3 or 5.
Correct. Also, your double bond is on 2, not on 3. So A is wrong for a number of reasons. And then you said the other one was?
I said C for the other one.
Why is C wrong right off the bat? Is there anything wrong there that you can like immediately like point out?
An ethyl group.
Nope, that's your longest chain. 1, 2, 3.
Oh.
So the only one you can immediately get rid of is A, but that's okay because sometimes you can get rid of, sometimes you can get rid of 2, but if you only get rid of 1, that's okay. So coming through here now, we have to figure out what Z. So is Z trans or cis? Is Z trans or cis, or you guys don't know? Yep. So Maggie, of course, I know you know that Z is, of course, German for zusammen, which means the same, right? So cis, obviously, I know you know that, all of our deep conversations that we have in German. E is German for etrogen, which means opposite. So that's trans. So chemistry has a long history in German, so German scientists account for most of our history. So that's why we do that. So a cis double bond, a Z double bond, means that the biggest substituents will be on the same side and the smallest substituents will be on the same side. So I labeled my hydrogens, right? So if I look here on the, if I draw a line through my double bond, hydrogen's the smallest here. What's smaller, the methyl or the ethyl? The methyl's smaller. So since they are on opposite sides, one's pointing up, one's pointing down, this would be E. All right, when I look at D, I do the same thing, and my methyl and my hydrogen are the smallest. This would also be E. And then I come here to this, and my methyl and my hydrogen are the smallest. They are on the same side, therefore it's Z. Does that make sense? Good on that? Okay. Let's go ahead and continue on. Question 4. What is the IUPAC name for this compound? Right off the bat, can I get rid of anything in these names? Yes, ortho only refers to what compound? We only say endo when we are referring to the benzene ring. Like if we have two things on a benzene ring, we don't use it when we do cyclo. So which one? Do you guys think it is, or are you stuck? Okay, I got D because you said that they are pointing in different directions. C, all right. Okay, so this is a important thing. So when we talk about so normally, okay, so when we do ortho is in reference to benzene, right? So we can eliminate benzene. Have you guys talked about endo at all in your class?
I honestly don't think so.
Okay, so
I can remember what it.
We normally use endo and exo when we have like multi-cyclic bridges, like we have multi-rings together, right? And we usually use endo and exo when they are referencing, basically it's a very specific nomenclature when you have like multiple rings. It depends on like what your group is pointing towards. Is it pointing towards the bridge carbon or the non-bridge carbon? And if I remember correctly, since we only have one ring, you don't use endo and exo. Does that make sense? So for example, and this is just an example, and don't like panic if this is like really freaks you out, but imagine I had a compound that had two rings like this. So there's one ring, and then I have like this bridge right here. If I had something coming off like this, like say bromine, then this is when I would use the term like endo or exo. In this case, it's endo. Does that make sense? When you use an endo, you have like two rings or more, versus when you don't, and you only have one. Okay, so since we only have one ring, we don't have to worry about the endo. And so then on this carbon, is the alcohol or H pointing up or down? All right, on this carbon, it's the bromine or hydrogen pointing up or down? It's pointing up. So since they are both up, right, one is axial, one is equatorial, doesn't matter, but they're both pointing up. So this one should be cis because they're pointing the same direction. Does that make sense? All right. Okay. Question 5. Which of the following compounds contains the following functional groups? Amide, ketone, ester, and ether. So which one of the following molecules contains the following functional groups? So I sit here and do nothing, be more worthless than usual. I sat and proctored a standardized testing today, so I read a Spider-Man comic this morning for an hour and a half. All kids took a standardized test. Okay, Matthew thinks hello, Matthew, welcome. I hope you did well on your exam. Especially since everyone got extra points. Interestingly enough, she doesn't have a correct answer on here. So on B, so in case this right here should be on this carbon, that should be on that carbon, that double bond. It's just slightly off. The answer is B. Are you guys completely unclear of how to solve that? So what might help, what do you think is going to help you in this type of problem, particularly, Mags, if you have a sheet next to your computer, what do you think might be useful to have? Functional groups, right? So if you draw them out, a ketone is going to be a carbon double bonded to oxygen. An ester is going to be this, right? You guys, I know you guys know your esters now because we did a lot of them. Oh, weird. An amide is this, and then an ether is that. So this one here, it has to be, it has to be connected to the carbon that's double bonded to the oxygen. So this one is wrong. This amine is not attached, this NH2 is not attached to any carbon at the double bond, so this one's wrong. You have an ester here, but you don't have an ether. So B is your only option. So here is your amide. Here is your ether. This should be your ester, and then this is your ketone. Questions? Because I think that's probably the one that got you guys the most so far. All right. You guys are awfully quiet today. Are you guys worn out? Is it because it's finals week is coming? Long year. That's fair. Year ago I was there. All right. Which of the following is E? 1,2-dichloro-2-pentene. Which one of these is 1,2-dichloro-2-pentene? Okay. Gwenifer is going to say C. That's right. I called you Gwenifer. We got A, we got B, we got A. So are there any of these answers that you can immediately eliminate?
I think I would eliminate B.
And your reason?
Because the pentene, so that it says pentene, so that means that there should be a double bond. So the double bond should be on 2. And
it is on 2.
Well, yeah, but where's the other Cl in this case?
That's it. It's not the location of the double bond. It's the fact that you should have 2 chlorines and you only have 1. So B is just wrong. Yeah. Any other one you can immediately eliminate. Actually, you can eliminate the rest of them pretty easily. Your double bond should start on carbon 2, and on carbon 2, you should have a chlorine. So there are no chlorines on these. There are no chlorines on these. Your only answer choice that makes sense is going to be A. Does that make sense? So this is why I said when you're taking this test, a lot of students forget, and I've been doing this for unfortunately a very long time. I'm so tired. Is that you can usually eliminate a good number of answers. Sometimes it's two, sometimes, sometimes if you're paying attention, you can eliminate them, right? And if we look here just to be sure, so if this is carbon 1, there's chlorine, carbon 2 has a chlorine and a double bond, 3, 4, 5. All right, so just as a double check, everything is in the right position. On the left side, what's my biggest group? The hydrogen or the ethyl? It's the ethyl, and you go by the first atom it's attached to. So on the right side, the biggest one is the chlorine because chlorine is bigger than carbon. So they are on opposite sides. So because of that, it's E. So A is your answer. We double checked it just to make sure, but it's the only one that even comes close to making sense. All right. Continue. 7, identify the weakest acid. Identify the weakest acid. Are you guys stuck on this one? You think A or B? Okay. So when it comes to acids, what makes an acid strong? Or what makes an acid an acid? Well, that's what an acid is, a proton, but do you guys remember we had those different things? So I'm going to share screen real quick. So remember when we talk about acidity, right? When I think about I have my base and I have my proton, what makes an acid a good acid is how easy, sorry, let me do this. It should be A, sorry. What makes a good acid is how easy this base can come and remove the proton like that. So things that will help make this is that if this is a electronegativity, remember, if you have a lot of electronegative atoms nearby, hybridization, sp is going to be more acidic than sp2, which is more acidic than sp3. How stable is the conjugate base, like after you take off the proton, so things like resonance. And then essentially the last one is what atom is it attached to, right? So if you think about in the same row, the same period left to right, atom furthest to right is going to be your strongest acid. If you think in the same period, it's the one that's going to be furthest down that's going to be your strongest acid. So going back to our problem, when we take the hydrogen, we're taking the proton, what are we leaving behind that's normally on a hydrogen? What subatomic particle gets left behind? A proton's positive because it has no what? Come on, guys. This is Gen Chem here, and organic. You only have 3 subatomic particles, so really, I'm telling you, you're taking the proton with the electron. Yes, you're leaving the electron behind, right? So when I think about a bond, like in this case, our carboxylic acid, which is this, right? Think about our oxygen, and then we have this bond here. Remember, a bond is 2 electrons. So the more electronegative this atom is, right, it's going to pull the electrons to the left. Okay, so the more electronegativity. So the more electronegative stuff that is over around your acid, the stronger that acid is going to be because you are pulling the electron density away. It makes it so much easier to pull this off because if I get a bunch of electronegative things there now and the electrons are really close, I can just pop off that hydrogen just by looking at it funny. So whenever you get this type of problem and you have benzene rings, your benzene by itself with nothing else on there is always going to be your middle option, meaning this is just standard. If I put electronegative stuff on the other side, it makes it more acidic. If I put stuff that has electron donating, it makes it less acidic. So C should be your correct answer. Okay. Now using that, since now we're talking about identify the strongest base, which one do you think this is? I'll give you guys like 30 seconds. Just come up with your best. Knowing that we were just talking about with acids, acids are stronger the more electronegative stuff are around it, like, and they're weaker when you have more electron donating. Which one of these do you think is going to be true? Nope, because that's what made it a, not going to be that one. Okay, so you're thinking C or D. In this case, it's going to be B. Gwen was right. It was B. And the reason why bases have like a lot of electron density, so the more electron density you put closer to your base, which in this case is the amine here on this side, this is going to be your, so if you put more electron density closer to it, it's going to be a stronger base. All right, time's about up. I'm gonna quit. I'm gonna come back. I need to grab a drink, so I'll be back in a couple minutes, and then we'll continue on.